it's a GATE CS 2019 numerical answer type question. So here they have given 4 processes with their arrival time in milliseconds and the CPU burst times they have given it. So the process are running on a single processor using a preemptive shortest remaining first algorithm. Okay. The average waiting time of the process is also given as 1 millisecond. So they are asking the value of Z. So here, okay. So here they are asking this value. So they are asking the process P4's burst time. Okay, fine. So let's tackle this now. So P1, P2, P3, and P4 four processes are given, and the corresponding arrival times are 0, 1, 3, 4, right? And the burst times are 3, 1, 3, Z. We have to calculate the Z. So we'll keep track of the waiting time of all the process also. Now let's draw the Gantt chart for SRTF algorithm, right? It is a preemptive algorithm. Okay, it's given as preemptive algorithm, right? And what is the mode we have to see? We have to see the minimum burst time. The criteria is minimum burst time, right? So whichever process has the minimum or the least burst time, that process should be taken and given the access of the CPU, right? Okay, so at time 0, only process P1 is in the ready queue. So I'll schedule it for 1 millisecond, right? So the remaining burst time becomes 2. So at 1, now P1 and P2 are in the ready queue. So now they will compete for the CPU. Since P2 has the lowest burst time, I will give access of CPU to process P2 for 1 millisecond. So the remaining burst time becomes 0. Okay. Next, the P3 arrives at 3 millisecond only. But till now, I have completed up till 2 milliseconds. So between 2 to 3 millisecond, I can give 1 millisecond to the process P1, which is in the ready queue, right? Yes. So the remaining process P1's ready queue becomes 1, right? Now at P3, before that, we have to keep track of the waiting time of all the process also. Till now, see here. So here the process P1 has waited now 1 second, right? Because process P2 has been scheduled between the two P1 processes, right? So it has waited for 1 millisecond, and process P2 has waited for 0 milliseconds, right? Because it has arrived at 1 millisecond and got scheduled at the first millisecond itself. So it has not waited at all. So its waiting time is 0. So now let's see. Now process 3, right, will come into the ready queue at the third millisecond. So now process P1 and process P3 will be in competition. Since process P1's burst time is lesser, I will schedule process P1's burst time again, right? So now we know that process P3 has waited for 1 millisecond, right? So now at the 4th millisecond, see here, now process P1 and P2 has completed its execution. Only process P3 and P4 still needs to execute, right? So at 4, process P4 comes in to the ready queue. Now we have to calculate the value of Z, right? So for that, they have given one more information, right? The average waiting time of the process is 1 millisecond. So average waiting time is 1 millisecond. That means waiting time of process 1 plus waiting time of process 2 plus waiting time of process 3 plus waiting time of process 4 divided by 4 is equal to 1. So which implies I can bring this 4 here, right, to the right hand side. So I'll remove this 4 and I'll keep it is equal to 4 itself. Okay, fine. So now till now waiting time of process 1 is here 1 millisecond and process P3 is 1 millisecond. So 2 milliseconds have already gone. So we have remaining 2 more milliseconds. So we have to keep Z value in a value such a way that it has to wait for 2 more milliseconds, right? So Z has 3 options. Okay, so what happens if I keep Z is equal to 3? Why I choose 3? Because between these two they have competition, right? So there can be 3 cases. Z is equal to 3, Z is greater than 3, and Z is lesser than 3. So these are all the three cases possible. So first I'll take Z is equal to 3. What happens if I take Z is equal to 3? Okay, so what happens is, so after 4, okay, so till here all remains the same. Now if I keep Z is equal to 3, so P3 will get scheduled, right? Because both have same burst times. So if both have same burst times, whichever process has arrived earlier, I'll schedule that, right? So next I'll schedule process P3 for 1 millisecond. So now this becomes 2. Again, there is a competition, right? So only P3 will get scheduled again because it has 2. 2 is lesser than 3, right? So again, 1 millisecond it will get scheduled. Again, 1 millisecond P3 will get scheduled, right? So for 3 milliseconds, now P4 should have been waited because it has arrived at 4. P4 is arrived at 4 and it has not got scheduled till 7. So the waiting time is 3 milliseconds. Okay, fine. Now I'll schedule the final process P4 for 3 milliseconds again because no more processors are there, right? So this becomes 0 and then this is the waiting time, right? So 3 plus 3 plus 1. So my waiting time becomes, this is the total waiting time of all the 4 processes. It should be 4, right? But I'm getting 5. So when Z is equal to 3, I am getting say 5. If Z is greater than 3, okay, what happens? If I keep Z is equal to 4, what happens? Again, the same thing. It will get the waiting time as 5 only. No changes. If you again follow this procedure, you will get the waiting time as 5 only. So for all the values of Z greater than or equal to 3, my waiting time will become 5 for all the process. Okay. Now, so I have to check for Z is less than 3, but Z should also be greater than 0, right? Since the burst time cannot be in negative or 0 value. So there will be only 2 options, Z is equal to 1 or Z is equal to 2. Okay. So now I have to check for Z is equal to 1 or Z is equal to 2. So I'll rub it here. So this one. Okay, I'll rub this one. Fine. So what happens? And this is also, I have to rub it, right? Okay. Fine. So I have to check for Z is equal to 1, right? At 4th millisecond, P3 and P4 are there. So I'll schedule P4 first because it has lowest burst time, right? So for 1 millisecond. So now P3 will have waited for 1 millisecond. It becomes 0, right? Then I'll schedule for which one? P3 for 3 milliseconds. This will become 0, right? So here see, now when I keep Z is equal to 1, my total waiting time 1 plus 1 plus 1 is 3 only, but I should get 4, right? So my Z value will most probably be 2. Let's check what happens when Z is equal to 2 also. Fine. I'll rub this also, okay? Then this also, yes. So here it was 3, right? And this also I have to rub it. Yeah, I'll check what happens when Z is equal to 2. When I keep Z is equal to 2, since 2 is also lesser than 3, I'll schedule P4 for 1 millisecond. So this becomes 1, right? So I have waited for 1 millisecond P3. Again, I'll schedule P4 only because 1 is less than 3, right? Burst time. So I'll schedule P4 again for 1 millisecond. So it has waited for 1 more millisecond. So after 6 only, P3 will get scheduled for 3 milliseconds. It becomes 9. So this becomes 0. So now my total waiting time 1 plus 1 plus 1 plus 1 is 4. So for Z is equal to 2 only, my total waiting time of all the process is 4 and the average waiting time is 1 millisecond. So what is the value of Z? Is 2.